Okay, so we've talked about how SQL supports dates, times, and I guess technically date times. We'll talk about how Python supports those as well. The primary reason to talk about how to handle times in both SQL and Python is because although SQL has a lot of functionality in what it gives you, Python gives you a lot more power to do more interesting things with the data than just the things supported by the SQL standard. So it's really important, especially for complicated data formats like dates, that you have a way to convert between what SQL stores them as and how Python stores them as so that you can work with them in both formats. So the module that handles time in Python is called datetime, and it contains 4 separate classes. A class called date, which represents year, month, and days. A class called time, which represents hour, minute, second, microsecond, and time zone. A class called datetime, which basically combines the above date and time together to be one package. And there's also a class called timedelta, which holds a difference in time between 2 of the above to represent a duration. Details will be linked here. If you just Google Python datetime, the module is well written, though it is complicated and long because representing dates and times is complicated. Okay, so let's start at the beginning. Datetime.date. So there are 2 ways to make this. You can either specify 4 numbers, the year, month, and day, or you can use the .today to get today's date. The way that you get information out of a date object is you use the .year, .month, .day attributes. So for example, if I wanted to specify, a couple weeks before Christmas of the year 2000, I could make a datetime.date object, and here I'm just saving it as D. And if I wanted to get out the year from D, I'd say D.year. That's how date works. How does time work? Much the same way. You specify hour, minute, second, microsecond, and all of these are assumed to be 0 unless you specify them. So you don't have to specify second and microsecond if you don't want to. You get the data out through the attributes as you would expect. How do you use it? Basically the same way you use datetime.date. Now we have datetime.datetime. Now the reason why I'm being really explicit, once again, the module is named datetime. The class is named datetime as well. It's confusing that they both have the exact same name in the exact same case, but that's the way the Python module library writers made it. We have to live with it. There are 2 constructors for datetime: year, month, day, hour, minute, second, microsecond, or datetime.now, which gets the current date and time. And you basically get all of the attributes that were in date and all of the attributes that were in time in one thing. So I can make a date time that specifies the moment right now, and I can ask for what is the day of the month. It is the 8th day of the month. What is the hour? It is the 1st hour. There's also time delta. There is a constructor for this where you specify a duration: days, hours, minutes, seconds. And once again, it'll supply zeros if you don't supply. So if you say 1 day, 2 hours, it'll assume 0 minutes, 0 seconds. So if I want to represent a length of time of 2 days, I would say datetime.timedelta days equals 2. And now we can actually do math, right? So if I want to say, hey, what is the moment 2 days from now? It'll be datetime.datetime.now. That represents a datetime that represents now. And a delta of 2 days, which we did before, and this would give us a new datetime object that represents a time 2 days from now. All right, so let's work through a slightly more complicated example. So this is all assumed in a Python file, and I'm running Python 3. First thing you do is you import datetime so you can use it. I want to get what is the current date time. And I want to get, hey, I have a very special date time in my heart, the day I was born, okay? I was born at 9 a.m. on November 1st, 1988. And so I want to figure out, how old am I right now? Well, the way you can determine how old you are is you need a time delta, and you can get a time delta by subtracting a date from another date. It is the difference in those dates. So my age represents the duration from when I was born till now. I could also generate a time delta. For instance, I can say the legal drinking age is 21 times 365 days. That's when you're 21 years old. Okay? And I can check, Am I old enough to drink? Well, I can say is legal to drink as like a Boolean is true or false if my age is greater than the legal drinking age. Now note, obviously, this doesn't take into account leap days and seconds. If you want to get into details for over long spans of time, you're going to have to read the module. I'm not going to ask you to do complicated things like that. All right. So we've been talking about date time objects, but what do we need to do when we want to stick it in the database? Well, we need to convert it to ISO 8601, the year, month, hour, year, month, day, hour, minute, second, so forth. Okay, so how do you do that? Well, all the datetime classes have a strf time. I think it's string format time method. I'm not sure exactly why it's called that. This method outputs a string according to a given pattern. Okay, so if we create a datetime object that represents, March 4th of 2015, and if I use the dt.strf time, and I pass in this pattern, which basically says, give me the 4-digit year, the 2-digit month, the 2-digit day, the 2-digit hour, 2-digit minute, 2-digit second, it will give me a string that's in ISO 8601. And you're welcome to just copy this little pattern whenever you need to convert datetime objects into ISO 8601. They also include a strp time to convert a string to a datetime object. So if you're given an ISO 8601 string, you can use this to get the appropriate date time. So it takes a string in ISO 8601 and a format, the same format that's actually up above, and it gives you a datetime object. So what does that look like? So I can say, hey, I want to make a new datetime.datetime object strip time to takes in a ISO 8601 representation, as well as the same pattern up above that specifies, hey, my string has year, month, day, hour, minute, second. And if you did everything right, the date time that you made up above by actually specifying hour, minute, second, and the date time that you made from the ISO 8601 representation will be identical to each other. The whole reason why we're using ISO 8601 is because SQLite doesn't store like Python objects. It doesn't store Python's datetime objects. It would be great if we could make it do that, but in reality, SQLite is made to interface with a lot of different things. It'd be really annoying for the SQLite creators if they specified, hey, and it can hold Python datetime objects. So instead, we convert all these datetime objects to text. So how do you convert a datetime Python object to text? Well, you use the strftime method to do it. And then when you got a datetime object in the database as this text format and you want to convert it to a Python datetime class, for instance, to do math like figure out which students in the class are legally able to drink, then you would use the strp time method to get it out. Okay. The other thing I want to mention is, although I mentioned earlier in SQL their date and time functions and doing durations over there in SQLite, the problem is using those functions can sometimes add information like microsecond precision or time zone info to them. So for the purposes of this class, we won't really ever be using those SQL date time functions. We'll be doing all of our date time complicatedness in Python, where we have a little bit more control over those sorts of changes.